Welcome back students. Now we are going to discuss about concentration of ores. Concentration is also known as dressing of ores, and in this what we do, we know that we obtain the ore from mining. So it is very obvious that it will have some impurity, rocky and sands along with it. So the process of removal of these rocky impurities known as gangue is known as concentration of ores, or also known as dressing. So let's start the study of concentration of ores. Concentration of ore. Okay, I have just informed you that the first step of metallurgy is obviously mining of minerals from ore, and after that we make them powder, and the next step is known as concentration of ore. We know that minerals are present in the earth crust, so it is very obvious that they have some sand, clay type rocky impurities along with them. So we need to remove those rocky impurity from the ore before we proceed further. So this method of removal of unwanted material like salt, clay, etc. from the ore is known as concentration or dressing of ore. Now why concentration of ore? Okay, let's assume I have a sample of unconcentrated ore, that means ore along with the impurities like sand, clay, etc. So in this sample I know that they are both impurities as well as ore, so the concentration of actual ore is very low because it has some impurity also. But if I remove all those impurities, so whatever I left behind is only with pure ore. So that means during this process concentration of ore in the sample is increasing, and that is why this is also known as concentration of ore. And there are different methods. We know that there are different type of metals, so they have different type of ores also, and the properties of ores of different metals are different. So that is why we need different techniques for the concentration of ores of different metals. And the first is hydraulic washing. In this, as the name suggests, simply we just wash the powdered ore with water. Ore particles are heavier, so they settle down in the bottom, and the gangue particles, gangue means rocky impurity like clay, etc. Gangue particles are lighter in weight, so they flow with the current of water current, while the heavy metal particles settle down. So in this way we separate the gangue particles and metal particles. So this is basically based on the gravity differences between ore and gangue particles. Generally the metal ores are heavier than the gangue associated with them. By flowing the powdered ore in current of water, the lighter rocky impurities can be washed away and the ore particles left behind. You can see here the heavier ore particles settle down into the bottom, while gangue particles, which are lighter in weight, they just flow away along with the water current. Next is magnetic separation, and this method is basically used if either ore or the gangue particles are magnetic in nature. We are aware of that iron and cobalt and nickel metals are magnetic, so obviously their ores would also be magnetic. So if either of the two, either gangue particles or ore particles are magnetic in nature, in that case this method is used for concentration of the ore. And in this what we do, that we have you can see two rollers and we have a leather belt. One of the two rollers is magnetic while another one is non-magnetic. So what we do at the one side, that means non-magnetic side of the roller, we put the powdered ore. This ore moves toward the magnetic end, and when the ore reaches magnetic end, obviously it has two components, one magnetic, another non-magnetic. Magnetic component is attracted strongly by magnetic roller, that is why they fall near to the wheel, while that component which is not magnetic is not attracted by the roller, so that is why they fall away, and in this way there are two different lumps. If I draw it again, it would be like this. I put here the ore particles, these ore particles reach here, and magnetic component falls near to the roller while non-magnetic component fall away. So in this way we have two different lumps with one magnetic, another non-magnetic. So this is the way they are separated. So magnetic field is applied to separate magnetically attractive particles from magnetically non-attractive particles. Next is actually force flotation method. As the name suggests, force flotation. This method is used for concentration of the sulfide ore or removal of gangue particles from sulfide ores. Actually, basically there are three types of ores: oxide ores, carbonate ore, and sulfide ore. If I give the example, then this is CuS, then calcium carbonate, we are aware of this, then iron oxide, Fe2O3. So there are basically three different type of ores: oxide ore, carbonate ore, or sulfide ore. So this method is used for concentration of sulfide ores, and this is based on the wetting property of ore particles or the gangue particles. What we do, that we take a container which is filled with water. Into this we add grounded powdered ore which contains both ore as well as gangue impurities, and then into this we add two things actually. The first is a collector, the first one is frother, and these are basically oils. Like in this we use pine oil, and the second one is a collector, which are actually chemical compounds with heavy molecular masses, and the examples are xanthates. Okay. Now these two play a key role in this process. What happens, that in this system we have water mixed with powdered ore which contains both gangue particle as well as ore particles. So, and ore particles are sulfide. So when we add actually frother like oil to generate froth, and then we add collectors. So what happens, first of all we add all these things here, and then we pass into the mixture compressed air. Because of this air, what happens, that there is formation of bubble. Obviously we know it contains the water contains oil, so when we'll blow air into this, oil will form bubbles and they move toward the surface to form froth. Okay, we have collectors also. Now first of all, what is difference between wetting characteristic, that the sulfide ores are not wetted by water, while the gangue particles, they get wet by water. That's why they become heavy and they settle down into the bottom, because they are nothing but clay particles, and clay and sand is easily wetted by water, so their mass increases and they settle down into the bottom, while the sulfide ores, they remain suspended into the water. And when air is supplied, there is formation of bubbles. But we do have collectors also. These collectors go and make a film around the sulfide ore, because of which now these sulfide ores get attached with the bubbles formed by blowing air, and they move with the bubbles on the surface, from where they are separated out easily. So what we do basically, in some summarized way, we just take water, into that we add powdered ore which has both ore as well as gangue particles. Into this we add oil and we add collectors like xanthate. Those collectors go into the system, and they make a film around sulfide ores which are not wetted by water. But on the other side, the clay particles or the gangue particles are soily, and that is why they are wetted by water. Their mass increases and they settle down into the bottom, while the sulfide ore particles are wetted by collectors. And when we blow compressed air into the system, we have frother like oil into that also, and that oil makes bubble, and the sulfide ore coated by collector get attached to that bubble and come on the surface, and from the surface they are just removed, and this is way the concentration takes place. Next is leaching. Leaching is actually a chemical method for separation of for concentration of ore. So what happens, that in this the ore is dissolved in suitable solvent, and the metal present in the ore is converted into soluble salt. From and the example, okay, so what is done basically, we dissolve the given powdered ore into some solvent, and then a reaction takes place. The ore particles are converted into the salt which is soluble, so they get dissolved actually, while the gangue particles remain suspended, or either they settle down into the bottom. The system is filtered and we remove the gangue particles, and then we again recrystallize the ore particles. In short, I can say here we have, let's say, a solvent. Into this I add ore. Then ore has two components, one is ore, another is gangue particle. Gangue particles are non-soluble, so they settle down into the bottom, while the ore particles get dissolved into water. So what we get gangue particles into the bottom, and as well as ore particles are soluble. So after that we filter, we remove the gangue particle which is present in the bottom, and then we get a clear solution which has dissolved ore into it, and then ore is precipitated from here. An example is, and this is known as leaching. Leaching of alumina from bauxite. Let's understand this with an example of leaching of alumina from bauxite. Bauxite is ore of aluminium. So what is done, that powder ore of bauxite is concentrated by digesting or dissolving it with concentrated sodium hydroxide solution at this temperature and this pressure. As a result, Al2O3 is leached out as sodium aluminate along with SiO as sodium silicate, leaving behind the impurities. Okay, let's understand. We had Al2O3, which is nothing but bauxite. This is then reacted with NaOH. Okay, this NaOH was aqueous form. This Al2O3 is in solid form, and also it contains some impurity. Okay, then what is done, and it contains some water molecules also which are liquid. So what happens at this much temperature and pressure, that I get two molecules of NaAlOH4 in aqueous form, dissolved form, plus impurity remains undissolved. Then impurity is filtered out or separated easily. So this is present in soluble form. Okay, now what I do, once I have removed all the impurities, I can again get back my ore by passing carbon dioxide gas into the system, and I again get Al2O3, hydrated Al2O3, along with two molecules of sodium hydrogen carbonate. So I started with impurity and ore, and at the end I have ore, impurity is removed. So this was the chemical method for concentration of ores known as leaching. Okay, now there is a solved problem that ores that are concentrated by flotation method are, okay, fourth flotation method, and those are sulfide ores we have just discussed. Next is magnetic separation is used to increase the concentration of, yes, they are used to increase the concentration when either impurity or the ore is magnetic, and we know that iron ore is magnetic in nature, so answer is D, magnesite. Magnesite is an ore of iron which is magnetic in nature, so magnetic separation method would be used for concentration of magnesite. So students, now we know very well that different techniques are used for concentration of ores of different elements. We use hydraulic washing, we use fourth flotation method for sulfide ores, and we use magnetic separation for those ores which are magnetic in nature. So different methods are used for metallurgy of different ores of different elements. So in our next video, we will move to the process which is used for extraction of the metal from concentrated ore. or in short we can say the extraction of metals from ore. So keep watching.